All right, third section in chapter 3, mean and standard deviation of group data. What group data is, it's basically data from a frequency table. And the problem with group data is basically what I've got sitting here on this problem here on this slide. It says the number of calls roadside services drivers in December 2003. Find the mean and standard deviation from this frequency table. Okay, well, to find mean, that means I would have to know all 31 numbers, add them up, divide by 31. The only issue with that is I've got one number right here. This tally means one number that's somewhere between 0 and 39. I don't know if it's 0, 1, 2, any number between 0 and 39. That goes for the next class and the next class and the next class. So it's kind of difficult to find that mean and standard deviation without knowing the raw data. So there's a method to finding the mean and standard deviation of group data. And it's basically this. You need to know the frequency table, and chances are that's given to you already because that's the issue. Okay? We're going to take the class midpoint. Okay, so within each class, we're going to take the lowest, highest, add them together, divide by 2. We're going to pretend that is the raw data. And in each entry, we'll call that frequency of f. We're going to pretend that every single instance in that class was the midpoint. Just because we didn't know if that number was 0 or 39, I'm going to pretend that that one number actually was the middle of that class, which is 19.5. Okay? I'm going to add up all those entries once I've done so, and really n and the notation of sum of f are the same thing because all my frequencies should add up to everything in that data. I just kind of treat this as if though that each number falls within that class. Okay, so the sample mean, you'll see something like this. It will say sample mean and frequency distribution. Now you've got this f. You are going to have to make sure that you multiply first and then add them up at the end. Divide by n. Sample standard deviation for this frequency table looks as such. There's a computational formula that goes along with it. I'll show you how to work with both. Remember, x is the class midpoint, f is the numbers of entries in each class, and n is the total of all of them. There is only sample standard deviation because we're using the midpoints as our best guess. We don't know the actual numbers of each of those numbers in the table that went into that frequency table. I might be going fast, but again, these formulas are in the back of the book. They are going to be given to you on stuff, and you could also print out the note packets too to get them as well. So I'm going to move on. I'm going to try to get through an example or two. Here's my frequency table. I walked in here. I've got my frequency table of this. It looked just as is without the beautiful table that I just drew. But it gives me the ages of 30 to 34, and I know that there are 4 people within that group. Okay, and so on 35 to 39, there's 5 people within that group, 2 people in the next group, 9 people in the next group. So the sum of all these f's ended up being 20. That's going to be my value of n that I'm going to use to divide by. Okay, x are your class midpoints. So I got this 32 by taking 30 plus 34 divided by 2. Okay. I have this 35 plus 39 divided by 2. That's how I got 37. But if I notice here, my class width for each of these classes, it's 5. So I'm going to use that magic number of 5 to just keep on adding 5 to get each of my class midpoints. You can go through to the average for all of them, double check it if you don't believe me. After that, I'm going to take each x times its frequency. So to get this 128, I took 32 times 4 because there's 32 is my class midpoint and 4 is my frequency. Did the same thing to get 185. I took 37 times 5. 42 times 2, 47 times 9 gives me those 4 products. Okay, went through and added those, and that's going to represent my 820, which is my sum of x times f. Okay, remember I said to make sure you multiply first. That's what we did. And then at the end, add them all up. So there is my xf, which is 820, divided by 20 to get an average or x bar of 41. So I'm going to use 41 as the average of that particular group. Yeah. Similar process. We're not. I shouldn't say similar to that, but I'm kind of. Well, not kind of. I got this mean 41 that I need to use in your standard deviation formula. Again, I don't have it written up here. I'll write it for you here real quick. But sample standard deviation is the square root of your sum of x minus x bar squared. Looks a lot like the one we've always been using, but now you're going to multiply each of those by frequency. Okay, and then you're n minus 1. So I did a similar process that we did before last section to find your standard deviation. You've got your x minus your averages. So 32 minus 41, negative 9. 37 minus 41 to get negative 4. 42 minus 41 to get 1. 47 minus 41 to get 6. Go through and square those numbers to get 81, 16, 1, 36. Okay, very similar to what we've done before. Now what we've got to do is we got to multiply by each frequency. So in my first class, there's 4 of them. That's how I got the 324. In the next class, that's 16. I'm going to multiply by 5 because there's 5 of them in that class, 80. Okay, multiplied by 2, there's 2 in that class. Multiplied by 9, and that's how you get the 329. Add all those up, and there's your sum of your x minus x bar squared times f. So I believe I got it worked out in the next slide. I'll double check real quick. I do. That sum was 730. Remember, the sum of all of the frequencies was 20. So that 730 is my numerator. And that n of 20 minus 1 is 19. Make sure you divide 730 divided by 19 first. That's how the 38.42 came about. Take the square root, and your standard deviation is 6.2. Here's another way. There's a computational formula, like I told you. I made 2 columns. I have one where I'm going to take x times f. So 32 times 4, 128. 37 times 5, 185. 42 times 2, 84. 47 times 9, 492. Add them up, and there's the sum of xf, which is going to slide right into there. My second table is going to be x squared times f. So I'm going to take each midpoint, 32, I'm going to square it, multiply it times 4. And that gives me some pretty big numbers. I'll go through and do that 4 more times. I'll add them up, and that's my sum of xf's, which is 34,350. So that's where that 34,350 comes into play. Okay. So I'm going to take 820, I'll square it, then divide by 20. Subtract those 2 numbers, divide by 19, take the square root, I still get the same answer. So whether it's the computational formula or the formula that we used on the flip chart before, they both work out to be the same standard deviation. Okay, kind of a matter of comfort. This is one of those deals where you're going to show me how to do it. And by the way, I just got done doing all this on here. I'll help you out with this in class. Um, Maybe show you some tricks or two to work through that as well. Get started maybe on page 130, 1, 3, 6, and 9. Again, we'll work through some in class. You'll do some in class. We'll practice that, and hopefully we get comfortable with finding the standard deviation of grouped data.